Okay, guys, welcome. Today we're going to talk about the use of graphics in the media. So, the first thing that we're going to talk about is what's called a multiple bar graph. Now, a multiple bar graph, of course, is just a simple extension of the regular bar graph where you have two or more sets of bars that are allowing you to compare two or more data sets with the same categories. So now if you have quantitative data, so again, quantitative means that we're looking at purely numerical data. Sometimes we'll also use a multiple line chart. So of course, this is a line chart just with more than one line used to display several different data types related to the same category. So in this first example, we're going to look at an example of each of those. So we want to say what general messages are revealed by the graphs in figure 5.12, which are these two graphs here on page 325. And we're going to comment on how the use of multiple bar and line graphics help convey these messages. So now in this first graph, we have a multiple bar graph, and we see the median annual earnings of full-time workers by educational attainment and gender. So of course, some of the general trends that you can see is that as the education goes higher, right? So you start from not a high school graduate and then high school graduate, some college, so on and so forth, all the way up to a professional degree, you see that the median earnings are generally increasing. Right? But another thing that we could also see is that if you look at our legend here, right? So our multiple categories here are for men and for women, and it seems that the men have the edge in each category, right? So it seems that men earn more than women based on this graph. So hopefully not true anymore, as this textbook is kind of old. But in this graph, that's unfortunately what's going on here, right? But that's the idea. And you can sort of quickly see that. And what's helpful about the multiple the multiple bar graph is that you can easily compare these things and you can easily sort of see what's going on. Now, in the next graph, we have a multiple line chart, and this is displaying the unemployment rates among individuals ages 25 or older by education level. So one thing that we can see is that it looks like all of these lines are sort of following the same trends, right? So between 1992 and 2000, we're decreasing, and then we have this little bump here, and then we decrease a little bit and shoot up. I guess that was around the recession, and then we sort of start to level off. So is sort of the general trend here. So we can see that all lines are following the same general trend. But of course, based on the level of education that you have, the worse that your education level is, or the lower your education level is, the higher the unemployment seems to be, right? So that's another thing that we're able to see fairly quickly from this graph. Okay. So let's look at the next example. So the Program for International Student Assessment, administered through the Organization for Economic Cooperation and Development, tracks the educational performance of students around the world. So it does this by administering standardized tests to samples of students from different countries every 3 years. In 2009, 15-year-old students from 65 countries took a standardized science test. Now, figure 5.13 on page 326, which I've copied here, shows results from 6 different countries, using 2 sets of bar graphs, one for boys and one for girls. Now, the first set of bars shows clearly that in the US, boys outperform girls on the science test, a fact sometimes used to argue that boys are inherently better than girls at science. But based on the overall graph, comment on the validity of this argument. Well, if you look at some of the other countries, we have that in Finland, Japan, and in South Korea, it looks like the girls actually do better, right? Whereas in the United States, Great Britain, and Denmark, the boys do better, right? So it seems that the achievement is fairly close together by country, right? But it seems that depending on which country you are, the boys will do better or the girls will do better, right? So it seems that no gender has a particular advantage. I should say neither gender. Right, because we have 6 countries total, and in 3 the boys perform better and 3 the girls perform better. So it doesn't seem like there's any sort of edge for either gender there. All right, so that's another example of a multiple bar graph. Now the next type of way that we'll talk about how you can show 2 or more related data sets at the same time, and that's with a stack plot. And this shows you different data sets stacked up on top of one another, right? And this is another thing that will allow you to compare data sets fairly quickly, right? Now, one thing that you have with the stack plots is you usually have some kind of total category that's being broken down into different subcategories. So for example, in this first stack plot here, you have the budgetary expense breakdown, and then each of these bars are broken into at least 2 categories and sometimes 3, right? And then this graph is showing you the different sicknesses that we have. And in this last one, we're showing the average estimated undergraduate budgets, right? So that's made up of tuition, room and board, other expenses, books and supplies, and transportation and things like that, right? So you're seeing the sort of the total being encompassed in that entire bar for each piece of data. Okay, so in this next example, we have that figure 5.15 on page 327 shows trends in the death rates, which is the deaths per 100,000 people for 4 diseases since 1990. So, sorry, since 1900. Now we want to know what was the death rate for cardiovascular disease in 1980, and what does that tell you about the general trends that are visible on the graph? Well, it looks like they marked these off for us. And we have that at the top, we have 620. And at the bottom of this, we have 180. So the difference of that would give us the death rates resulting just from cardiovascular disease, right? So if we subtract them, we'll get a 440. Right? So it looks like the death rate was 440 deaths per 100,000 people for cardiovascular disease. Okay. Now, what are some general trends in the stack plot here? One general trend that's encouraging is that the death rate for these diseases is going down, right? So of course, all 4 of these give you the total, and that is generally decreasing. So one thing that we could say is that the death rate from these diseases is decreasing. Right, and it seems that the first 3 for pneumonia, tuberculosis, and cardiovascular disease, it seems that all 3 of them seem to be thinning out, and even tuberculosis seems to be essentially gone as time goes on, right? But those top 3 seem to all be going down, right? And then, of course, the one thing that is increasing is this bottom one here, and that's cancer. And it seems like cancer seems to be slowly but surely contributing to the death rate, right? Okay. Now, next we'll talk about how we can look at graphs of geographical data. Now, there's several ways that we can display geographical data, and one example is color coding regions of land. Now, if you have data that will change over geographical boundaries, another thing that we can use is what's called a contour map, right? So we're going to look at an example of this. So we're going to use these 2 figures to answer the following questions. So now, what geographical characteristics are common to states with the lowest energy usage per person? So let's look at our energy use per person graph here. Now, which are the ones with the lowest energy usage? Well, it looks like we have, it looks like this orange is going to be our lower energy usage place. So it looks like that's Hawaii, Florida, some of these states in the Mideast here, and then some of these here. Right? Now, one thing that you might be able to see here is that these are the, well, we can't see it here, but it's known that these are densely populated states. Right? Now, what's true about densely populated states? Well, you have a lot of things like, you have a lot of shared services, we could say. And what I mean by that is you have a lot of buses that are used, you have apartment buildings where utilities are sort of shared between people. Etc. Right, so because these states are so densely populated, but you're sort of utilizing these shared services, that's going to cut down on the average cost per person, right? And you can see sort of on the other end, you have states like Wyoming and Alaska, which are not densely populated, and that would tell you that you're not getting those shared services. So everybody needs their own house and things like that, right? So that's sort of an example of using the per person energy state map, I should say. Okay, now were there any temperatures above 80 degrees Fahrenheit in the US on the date shown in figure 5.17? Okay, if so, where? Now it looks like here is our contour map for temperature, and of course, since this varies over geographical boundaries, this is the more appropriate way to do that. Now, if we look, it looks like down here, we have 80 degrees. All right, so there's the answer to your question. But you can see that you have so here you can see that you have different temperature regions for appropriate places within the country. All right, so that's sort of the idea here. Okay, now the next type of graphics that we'll talk about involve utilizing three-dimensional graphics. And they're a nice way to visualize and represent several data sets without having to make multiple graphs. So for example, based on this figure, about when did China surpass Russia in total carbon emissions, right? So now you can see that we have multiple data sets being shown here, right? So we have countries on this axis, we have the years on this axis, and then we have the CO2 emissions on this axis. And we're specifically looking for, well, when did China surpass Russia in total carbon dioxide emissions? Now it seems like if we look here, so China looks like these yellow bars and Russia is those light blue bars. Now it looks like in 1990, the light blue one is a little bit bigger, but in the next one, the yellow one is much bigger. So it looks like between 1900 and 1995, sorry, 1990 and 1995 was when China surpassed Russia in total carbon emissions. Right, so that's an example of reading a three-dimensional bar graph there. Okay, now the next type of graphic that we'll talk about is what's called an infographic. Now the goal of an infographic is to present a large interrelated set of information in a visual way that's nice to interpret and it's easy to read, right? So based on that, we're going to answer the following questions based on this first year students infographic. So in part A, we want to know what year did the survey students enter college, okay? So we have this nice graphic here, and it looks like we can find fairly quickly that the students entered college in 2012. Now, what made 30% of the students feel overwhelmed? Well, let's see. Can we find what makes students overwhelmed? Looks like right here. And it looks like if we zoom in and it says frequently overwhelmed by all that they had to do as high school seniors. Okay. So if they had to enter college, it looks like their senior year obligations overwhelmed them. Right. So things like applying for college, filling out applications and things like that. Now, part C, why is there an arrow with a question mark at the beginning of the fourth row? Could it be misinterpreted? Right. And of course, there's an arrow here because they're talking about frequently asked questions. And I guess it could be misinterpreted here because when you're looking at an infographic about college, 57% and seeing that question mark might lead you to believe several different things. But here it's simply just representing that we're asking questions. All right, so that's the idea behind this infographic. All right, now the last couple types of things that we'll talk about to look out for in graphics are the following. Now the first one is when you have perceptual distortions. Now some graphics may be drawn in a way that distorts our perceptions of them, and they can cause you to feel an exaggerated effect of the graphic. So let's look at an example of that. Now in this figure 5.20, we have that the lengths of the dollar bills are proportional to their spending power. All right, so what we mean by that is that this represents $1, this represents 63 cents, and this distance represents 39 cents. Right now, of course, you're also drawn to the areas as well, right? So with these lengths changing, you're also having the widths change. So you sort of preserve the, the correct image of that dollar bill there. But you're sort of feeling this exaggerated effect because really what you should be paying attention to is those blue lengths here. But you're also sort of drawn, by accident or on purpose to the areas of the dollar bills as well. Okay, now the next thing to look for is to watch the scales. Now scales can appear to be less dramatic when different intervals for scales are used, and the increments can also be different when different scales are used. So let's see. Now in figure 5.21, we have that both graphs are showing the same data, right? But of course they look very different. In this first one, it looks like these, what are they showing here? I guess it's percent women. Well, it's percent women for something. I forgot to grab the title of it. But the idea is that in this first graph, it looks like we're having this drastic change because we're going up and down fairly quickly. And in the second one, it almost looks like it's staying constant. But the reason why is because this is zoomed in from 30 to 60, whereas this is going from 0 to 100. All right, so that's something that you have to watch. All right, and now in the same effect here, both of these graphs show the same data, but again, look at your scales. This is powers of 10 here, so it's almost appearing that your graph is linear. But here, now your axis is in billions of calculations per second, and that almost looks exponential, right? So that's something that you would have to keep an eye out for is how are the scales changing. Okay. Now we can also talk about percentage change graphs, and they may lead you to believe that change is either no longer happening or is not happening as dramatically. Okay. So remember what percentage change is. Percentage change takes into account how much are you changing compared to your previous setting, right? So it looks like for this percentage change, we're increasing by around 6% for a couple of years, and then it drops down. And then we have this sort of fluctuation here, right? Now, if you compare that to the actual data, even though you have increasing and decreasing for all these percentage change uh, in college costs here, the actual cost is going up every year, right? And that can sort of be misleading, because if you see the changes in college costs based on this graph, you might say, oh, well, it's sort of fluctuating. But here, you sort of get the true story, and it's not fluctuating, right? It's consistently increasing. So that's something to sort of keep in mind. Now, the last thing that we'll discuss is when you have a pictograph, and of course that can have an additional, it can have additional artwork which can sort of distort or hide some of the different meanings that they're trying to convey. Right. So here you have the world population in billions of people, right? So you sort of have this extra picture going on in the background, right? This globe with all these people is not really part of the data, but it's just sort of for added effect, I guess. Now, another thing to note here is that the scale is not increasing linearly, right? So it might seem that the world population is increasing linearly, but if you pay careful attention, excuse me, to that axis, you see that it's not linear, right? So you're actually getting some sort of exponential growth here. All right, but that concludes this video on graphics in the media. I hope you enjoyed, and I will see you next time.